What is going on, guys? This is your next assembly language tutorial. I guess this is the 10th one. Not that sure though. So let's get started. Let's go ahead and try and complete our code for displaying the value on the screen. Now, I think this is pretty clear to you all. We move 04 to CL, and then we roll BX by CL, and we select the least significant 8 bits, and then finally we end up selecting the least significant character itself, right? So by using this logic, you've selected the correct digit. But another important thing that we forgot in the entire procedure was that we need to perform the conversion, right? We never really performed the hex to ASCII conversion. Now we have the value 2, but whenever I use the function 02h, what it's going to do is it's going to look at 2 and it's going to say, all right, this is a hex value. So I'm going to look up in the table. I'm going to find what is the symbol corresponding to the value 2, and that symbol is going to be something else. We don't want that symbol, right? We want the value 2. And so we saw that whenever we add 30 to a digit between 0 and 9, we get the symbol corresponding to that particular number, right? So for 2, if I add 30 to it, it becomes 32, and 32 is the hex code for the value 2, right? So uh, we really need to write a simple if statement over here. So let's go ahead and write that. And to do that, what we need is a CMP instruction. The CMP stands for compare. It compares two values. So I'm just going to go ahead and write compare DL comma 09. It's going to compare the value in DL, which is our digit, to 09, and if it's less, then it's going to add 30 to it. But if it's more, remember when I showed you the difference between the hex A and 41, which is the hex code for the symbol A, the difference came out to be 37, right? So what I'm going to do is, if it's less than 9, I'm going to add 30 to the value, and if it's greater than 9, then I'm going to add 37. All right, so now to add 30 to it, this is what I'm gonna do here. I'm gonna say that if it's JBE, which stands for jump if below or equal. So I'm gonna say that if it's less than 9, that is jump if it's below or equal to 9 to a label, right? Label. All right. So I want to jump to the label. So what am I going to do over here? I'm going to create that label, and in the label I'm going to start writing some code, right? So what code am I going to write inside the label? Inside the label I'm going to write the code add TL comma 30h, right? And what after that? I'm just going to print. So how do you print it? Move AH, which is your command register. You move all of your commands to your AH register. 02h, which is the function to print a single character on the screen. In 21h will print the character, right? So with this done, I'm done with one condition, which is jump if below or equal to this, and it's done, right? Now what if it's greater than 9? If it's greater than 9, I want to print A, B, C, right? Depending on whatever it is. So if it's greater than 9, I don't have to, I can write jump if greater than equal, but I don't have to write that, because let's say if it's below or equal, it goes to label, but if it's not, it does not jump. All right, so if it does not jump, what is the next line I need to write here? I need to write add DL comma 07h. Now why am I writing DL comma 07h? Now this was a question which was asked to me, and I answered it incorrectly when some of the people asked me in the class as well. Now I wanna correct that mistake right now, and I really apologize for that mistake. The mistake I made was that when you jump to the label, it executes this part, which is correct. But if you do not jump, it just executes this statement. Now when I said that, I was wrong. If you do not jump, let's say the condition turns out to be false and you do not jump to the label, what really happens is it goes on to the next statement and it executes everything from there line by line. Okay, so when I say add DL07h, what's going to do is it's going to add 7 to the value, and it's going to go to the next line even though it's a part of the label. It is not going to care if it's a part of the label or not. It's still going to go to the next line and add 30 to the value, right? So in all, we're adding 37, which we originally needed to add, right, to convert the hex A to the symbol A. So if it's not, it's going to add 7, it's going to go down. All right, I'm adding 30 as well, so it becomes 37. I get the value A, I print the character on the screen. All right, now next what we need to do is we're gonna want to decrease our original loop variable, which we can do by writing decrement ch. And what this really does is the roll procedure that we're doing it for one word, right? And we're supposed to do that 4 times, if you remember correctly. When I say 2 3 4 5 rolls to 3 4 5 2, we get 5 2 and 2. This is for one particular value. So to get the entire 2 3 4 5, we need to repeat this entire procedure 4 times, right? So my original value of ch was 4. I decrement ch. Obviously I should have a condition, right? So jump if non-zero. All right, j and z is jump if it's not zero, that is ch is not zero. You jump where you're supposed to jump back, right? And where you're supposed to jump, you're supposed to jump to this statement where I move 4 to cl, right? So I'm gonna have to define another label. I'll make that label 2. Jump j and z label 2, and let's go ahead and make our label 2 over here. Alright, this is my label 2. Let me make this label 1 so that makes more sense, right? So this is my label 1, this is my label 2. I'm jumping here to label 1, I'm jumping here to label 2, and let's say this condition turns out to be true, and I'm sorry, false, and this actually, the value in ch becomes 0. So we're done with the first word, right? So what we're supposed to do now is we're supposed to somehow go to the next word, right? We're done with the first 16 bits. I mean the least significant 16 bits. Now we need to go back to the most significant 16 bits and repeat the exact same procedure again, alright? So what am I going to do now? Well, I'm going to compare my original variable, compare dh. I'm going to compare that to 0. I can alright, another important thing right here, right now. When I say decrement ch, after the decrement statement, whenever I write a jump if non-zero statement, it's automatically going to consider ch. Alright, so now what I'm going to do is that I'm going to do the same thing to my outer variable, right? My inner variable has been taken care of. Now I'm going to decrement my dh. I'm going to jump if non-zero to label 3, and where my label 3 is going to be is it's going to be right here, right? Move c at 0 4. Why? Because in my label 3, which is my outer variable, I want to repeat the entire thing. And if you remember, my ch was for the word, right? How many times do I have to perform the roll operation? That was what ch meant, right? And so we want to repeat 4 times for the new word, and so we're going to move to label 3. Now we said, okay, new word, but we never really did that, right? In the entire procedure that I've written over here, I'm working with the bx register, alright? But I never really made bx point to the new word. I should do that, right? Because if bx is having the same value, this thing is just going to repeat with the same value, and nothing's going to happen. So before I jump to my label, here's what I'm going to do. I'm going to move to bx word ptr Barney. Why? Because bx right now had the most significant 16 bits, right? It had 2 3 4 5. We are working on 2 3 4 5, which is the first part of our answer. When we're done, what we're going to do is we're going to assign bx word ptr Barney, and what that means is that by default word ptr is going to return the least significant 16 bits, or the last part of your answer. All right, if I write Barney plus 2 here, it's going to return the most significant 16 bits. Alright, so because it already had the most significant 16 bits right here, what I'm going to do is I'm going to choose the least I'm going to choose the least significant 16. I'm really sorry about that. I'm going to choose the least significant 16 bits of my answer, right? I'm going to display them. So this is what I'm going to do, and then I'm going to decrement dh, and then I'm going to jump to label. So I think this kind of completes my entire program. Let me go ahead and try and run this. Should work, hopefully. Open up command prompt and clear the screen. cd desktop cmp s And what we're gonna do is TASM add.asm. Oh, we're getting an error. Can't locate file add. Oh my god. Oh, I have it on my desktop. Oh my god. I'm so sorry about that. Let me just move this from my desktop to the right folder, which is MP, because that is the folder which has my TASM, T-Link and RDM files. Let me bring this right here and my command prompt right here. CMS TASM add.asm, no errors. T-Link add.obj, no problems again. Oh, what just happened? Look at the answer. This is the answer, 2, 3, 4, 5, 6, 7, 8A, right? This is what we wanted. So we've done it. Wow, this actually works. Yeah, let me be honest, I was really confident if this was going to work, but it worked, right? So you finally know the logic to print something on the screen, and once you get the hang of this logic, you can print almost anything you want on the screen. So all of those programs in which you had to access the dump in order to view the output can be changed by using this logic, right? I'm going to try to do that in the few programs that I'm going to be uploading after this, but for now, this is it. Yeah, I'm done with this one. Thank you guys for watching, and before I say bye, Barney is awesome. Bye bye.